Okay, in this video we're going to be talking about connected graphs. And if you have a book, it says we're going to be dealing with section 4.3. So let's go and get started. A connected graph is a graph where every vertex is connected to another vertex. So like, let me give you a for example. Let's say if we had vertex A, and then this was vertex B, and then we had vertex C. If I was to draw an edge just connecting all three in one way or another. That would be an example of a connected graph, okay? And there's many different ways that these could be connected. This is just one way that you're looking at. It could also be, there's an example of a connected graph. So, I mean, there's really no set standard, but there is one thing that I need you to understand. In order to determine whether or not something is a connected graph, think of it as if you were to pick up vertex A, meaning if you were literally to pick up that vertex from the piece of paper, would the entire graph go with it? Meaning, would all the parts, all the edges, all the vertices go with it? And if the answer is yes, then you have yourself a connected graph. Now, let me give you an example of something that's not necessarily connected. Let's say if I was to draw maybe two more vertices. This was vertex D and this was vertex E, and I just went ahead and connected them with an edge. Notice that this graph here, I added E and D. That's not connected. See, you have an edge that is just overlapping the other two edges, but it's not actually connected. So this would be an example of a graph that was not connected. Now, if I was to then take an edge connecting E to A, then yes, everything is now connected. Okay? If you would like to see another example, this is an example of something that is not connected, because if you notice F and G, kind of like the example I just gave you. But if I just asked you, the question is A, C, D, B, and E, just looking at those vertices, is that a connected graph? The answer would be yes. All right, let's keep going. Another term I would like you guys to be familiar with is what is called adjacent vertices. Now, you already know what vertices are. Those are 2 points. So like points A and C. Now, the reason that they are adjacent is because they are connected to each other with an edge. So notice the edge that is between C and A, then you would say C and A are adjacent. But let's say if I was to ask you, is B and A, are they would they be considered adjacent? The answer would be no, because of the fact that there is not an edge connecting both these two. So in so just review, adjacent vertices is when you have two basically two dots being connected by a line. And if not, then it's not adjacent. All right, let's keep going. Now what we're going to be talking about is how to create a graph. Okay, now the way that you were given in this example is you were giving a list of all the vertices and all the edges. Now this is actually kind of an easy concept to understand. Notice that all the vertices A, B, C, D, and E are all represented on the graph itself. Now, another thing I want you to also take notice of is the edges. The edges will also be listed. Notice that AC, see this edge AC? There it is. CB, here is the edge right here. Okay? CE, so on and so forth. You can see how everything is listed on here. So if you were given an example of uh, this and you're saying, okay, create for me a graph using this information, then the vertices will be given to you and just connect everything according to the edges. So let's do a quick example. All right, the example we have are these down here. Notice that we have vertices A, B, C, and D. So the way that you would set them up is just write down all your vertices, A, B, C, and D. I always like to kind of start off with more of a circular pattern. All right, now you have edges AB, so I'm going to connect A to B, B to C, A to D, and then lastly D to C. And there you have it. But let's say if I went ahead and added one more edge, and if I added BA. Now you might be saying, well, there's already an edge connecting that. Well, in this case, this would also have to be represented by drawing another edge connected to them. And so what we have are multiple edges going to the same vertices. Okay, another example to take a look at is this construct a graph with the following set of vertices. And vertices A, B, C, D, E, F, or I'm sorry, A, B, C, D, and E, and then the edges there. If you want to try this, pause the video right now because I'm about to show you the answer. All right, so hopefully you paused it and you have already done this, and so we're going to check our work off of mine. There you go. That's what it should look like. Now notice at this point in time, you should know that graphs are always going to have a little bit of difference with the way you draw it, but all the connections should be there. So A should still be connecting to B, C, D, and E, so on and so forth. All right, another way to draw a graph is what is called an adjacency matrix. Okay, an adjacency matrix, it will always be a square matrix, okay, to whereas the number of rows, number of columns will be uh, will will be the same. Now, a couple things to notice is that on an adjacency matrix, it will tell you how many edges are connecting to uh, adjacent vertices. So, like for example, let's focus on this edge right here. Okay, now this edge right here is connecting A to C. So the way that you read this is that you would actually read it to the right, or I'm sorry, yes, to the right. Notice if you look at A, notice how A and C has a 1 when you connect the A row to the C column. But also, it will be represented here as well, because the adjacency matrix gives you who is adjacent from every vertice's point of view. So that means that one edge would be represented more than once in the adjacency matrix. So like if you haven't picked up on this now, look at this edge right here. It's connecting B to E. Well, B to E is represented here, that one there, as well as that right there. All right, pretty simple. Now, let's kind of add on this a little bit. Let's say, for example, there's a 1 that's right here, A to A. Well, how would you represent that? Well, you would represent that like this, and that is called a loop. Let's see if I can write that with my mouse here. That is called a loop. All right. Now, also, let's change this a little more and put a 2 right here, which means this right here will be a 2. So now there's a 2. How will that look like? Well, let me just show you. If you remember, that is the edge that we were referring to, and since we have a little 2 there, now we would have another line connecting the 2. So there'd actually be multiple edges. So that's how you would do that. All right, if you would like an example, here's an example that you're looking at right now. Pause the video right now, and because in another second I'm going to show you the answer. So go ahead and pause it. All right, hopefully you've worked it out, and this would be the answer. And remember, yours might look a little different, but all the connections should still be the same. So if you got it right, congratulations. All right, some other things to take notice or pay attention in this section, that's what I was trying to say, is that this is a multi-graph. This is an example, what I'm highlighting is a graph that has either a loop or multiple edges. Now, of course, you know what multiple edges are, is that is when there are multiple edges connecting to vertices. Now, a loop is this thing right here, and we drew that about 2 slides ago. So hopefully you guys will get that. Now, of course, if I'm going too fast, feel free to pause the video so you can take notes. All right, the last thing we're going to be talking about is what is called a degree, or I believe it's called valence. Now, I'll never call it valence. I'll always call it a degree. And it's the number of edges that a specific vertex has. So basically what you're doing is in short, you're figuring out and counting all the lines that are connecting to a vertex. So like, let's look at C, for example. C has this edge, this edge, this edge, this edge, this edge, and this edge, all connecting. So that'd be 1, 2, 3, 4, 5, and 6. Now another thing to pay attention to is notice I'm sorry, A has a loop attached to it. It has one edge and then it has a loop. Well, that would count as 3 because a loop counts as 2. All right. Hopefully you guys learned something in this video and let me know if you have any questions. Thank you.